Here's a deceptively simple Python challenge. Convert 1/2 to an integer. Most beginners guess 0.5 or 1. The answer is 0. And the reason why reveals everything about how Python evaluates expressions. By the end of this video, you'll predict not just the value, but the type of any arithmetic expression you write. Before we solve that puzzle, we need to know what Python is doing when it sees an expression. An expression is the simplest unit of computation. The pattern, object, operator, object, 3 plus 2. Each side of the operator is called an operand. The plus is the operator. Together, they form something Python can evaluate. When Python evaluates this expression, it doesn't keep the recipe. It keeps the result. The expression collapses into a single value. Watch this collapse in memory. Write x equals 3 plus 2. Python sees the expression on the right side. It computes 3 plus 2, producing 5. Then 5 gets stored under the name x. The original expression is gone. Python doesn't remember that x came from 3 plus 2. It only remembers the result. This is the foundation. Every expression, no matter how complex, collapses to one object. That single object is what gets stored, returned, or passed along. This collapse rule explains nested expressions. Consider type of 3 plus 2. Python evaluates the inside first. 3 plus 2 becomes 5. The expression now reads type of 5. Then the outer call runs, returning int. Inside out, always. Every nested expression follows this rule. The inner result replaces the inner expression, and the next layer operates on that value. No exceptions. Python has 7 arithmetic operators: plus, minus, star for multiplication, slash for division, double slash for floor division, percent for modulus, and the double star for exponentiation. 2 need explanation. Floor division means divide, then drop the fractional part. 5 floor divides 3 is equal to 1. Because 3 fits into 5 once, modulus gives the remainder. 5 more 3 is equal to 2. Because after fitting 3 in once, 2 is left over. Exponentiation, 2 to the power of 3 is equal to 8. These 7 operators are the entire arithmetic toolkit. Everything else builds on them. The rule sounds simple until you mix types. Here's where it gets interesting. For most operators, if both operands are integers, the result is an integer. 4 times 3 returns int. But mix in a float, and the result becomes a float. 4.0 times 3 returns float. One operator breaks the pattern, slash true division. It always returns a float, even when both operands are integers. 1 divided by 2 returns 0.5, a float. This is intentional. Older Python versions made slash do integer division, which surprised users. Modern Python made slash always float and added double slash for floor division. Now precedence. When operators mix, which runs first? Python uses 3 tiers. Top tier, exponentiation, double star. Middle tier, multiplication, division, floor division. Modulus, bottom tier, addition and subtraction. Higher tiers run first. Within the same tier, evaluation proceeds left to right. Parentheses override everything. If you wrap an expression in parentheses, it evaluates first, regardless of operator precedence. When in doubt, add parentheses. They cost nothing and they document intent. Let's walk through a tricky one. 13 minus 4 divided by 12 times 12. The minus sign is bottom tier. The divide and the multiply are middle tier, so they run first. Within that tier, evaluation goes left to right, so 4 divided by 12 runs first. That produces 0.3333, a float. Now the expression reads 13 minus 0.3333 times 12. The multiplication runs next. 0.3333 times 12 equals 4.0, still a float. Finally, 13 minus 4.0 equals 9.0. The result is 9.0. Once a float appears, every downstream value becomes a float. Call it float contamination. Now look back at our opening puzzle. Convert 1/2 to an integer. Inside out, 1 divided by 2 runs first. slash always returns float, so we get 0.5. Then the outer call runs, convert 0.5 to an integer. Here's the key. Convert to integer truncates. It drops the fractional part, moving towards 0. 0.5 truncates to 0. Mystery solved. Expressions are the atoms of every Python program. Loops, functions, conditionals. They all rely on this evaluate to single value rule. Mastering precedence and the resulting types means you can predict what your code does before running it. That's the foundation of debugging. When in doubt, add parentheses. They cost nothing and they make your intent unmistakable to both Python and the next person reading your code.